Good morning, everybody. Am I audible?
Morning, sir. You
Yes,
are
sir, you're
audible.
audible.
Yes, sir. Yes,
Good
yes,
morning,
sir. Very
sir.
loud and clear. Good afternoon, sir.
Okay, good afternoon, everybody. A very good welcome to the students who have newly joined, especially the lateral entry students. So, very warm welcome to you for your first class on basic electronics. We have been already been conducting this class, so you are a little bit you have to accustom with the class uh, because already we are here. We have completed the first modules up to two modules we have completed. We have completed our modules of semiconductor physics. Then we do our basic instruments, and then we discuss about the diodes. In the diodes, we have already completed our normal semiconductor diodes, its
Good afternoon,
applications.
sir.
Good
Your voice is
afternoon.
not audible, sir.
My voice is not audible.
Audible, sir. Audible, so
Sir,
we can hear
audible
you.
but not clear.
Those who will have a problem, I think there is a network problem in your end, so you must disconnect and again reconnect for this, for your betterment, because I think from my end the network is good, and I request everybody to those who will have some problems. Yes, sometimes there is some problems, but if you have some problems, we will sort it otherwise. Okay. So what we are telling that it is a request for the students who have newly joined, especially the our lateral entry students who have joined today for our classes. We have already been gone through what things in your basic electronics. Let me discuss it first thoroughly. This is a two-period class, so actually I take all the periods at two periods. One is today and another is on probably Wednesday. So what we are going to learn in this basic electronics is that we will be familiar with the different electronics devices that we are using in our laboratory and as well as electronics department. In that, we have already discussed our instruments that we are using. We have also discussed about the semiconductor physics of electronics, which has already been learned by you in your uh, 12 classes as well as in your diploma classes. You have done the diploma, so it will be learned by you the basic electronics. And what we have discussed thoroughly about the uh, 1 minute. I think there is a pending students enrollment. Yes, I have done that. So there is a discuss about our diodes, their semiconductor diodes, and we means we details in details we have discussed about the semiconductor diodes and its applications. We have also done the numerical calculations on this semiconductor diodes. In this teachment platform, you will get all the notes, all the videos that I have conducted. So the students who have joined today have missed the classes, you are requested to go through that videos as well as the study materials. If you have some problem or if you have some curiosity or some questions in your, please write it down in the chat box or write it down in this page, Teach Me platform. I will try to give the answers as early as possible, and we will going to conduct some what remedial classes for the students who have that actually for the laterality students who have joined the sessions very late. We will do the remedial class where we will discuss about the topics that you are facing problems and all that things. I think it will be not problem for you to cope up with this class because we are starting today a fresh chapter, and before that we will continue from our last classes, last class what we have taken, and there we have not completed one of the special diodes. Today we will talk about that particular special diodes, and then we will go to the next chapter, that is transistor, which is an important device in our electronics. After the diode and the special diodes, it is one of the most important device in our electronics. So we have to learn by heart or learn in depth about this device. So let us, without further delay, without further interaction, we have finished the introduction. So without further delay, we are going to start the actual, we are going to start our class today. And we will start by describing a special diode. There are some special diodes we know, and one of those special diodes that we are going to discuss today. After that, we will go for the transistor biasing and all the things. Okay, so let's start. Just a minute. So let us share the whiteboard. So everybody can see the whiteboard now.
Yes, sir.
Yes, sir.
Today is 24th, 1, 2022. and we will continue with our special purpose diode. So there are two left, our special purpose diode. Number one is our varactor diode. So we will start discussing about the varactor diode. So what is actually a varactor diode? Varactor diode are those diodes which act as a variable capacitor under changing reverse bias is known as varactor diode. So a junction diode which acts as a variable capacitor under changing reverse bias is known as varactor diode. So this is the actual definition of a varactor diode. A junction diode which acts as a variable capacitor under changing reverse bias is known as varactor diode. So if I draw the block diagram as well as the symbol of this varactor diode, it will be like this. So this is the P, this is the N, this is the lead, this is minus, this is the positive lead. This is the depletion region. This is the effective plate. This is effective plate. This is also effective plate. And this is the effective dielectric. And the symbol of this vector diode is like this. So these are the symbol and schematic of an directed diode. Now, when PN junction is formed, depletion layer is created in the junction area. Since there are no charge carriers within the depletion region, the zone acts as an insulator. The p-type material with holes as majority carriers and n-type material with electrons and majority carriers acts as a charged plate. Thus, the diode may be considered as a capacitor with N region and P region forming oppositely charged plates, and with the depletion zone between them acting as a dielectric. A birected diode is specially constructed to have high capacitance under reverse bias. The values of capacitance of birected diode are in the picofarad range. So understand what is birected diode. That is the birected diode. Now, work on operation. This is the symbol. Some students have requested to join. This is 1, 2, this is 3. So this is the symbol of birected diode. And this is the schematic. Block diagram. Now the theory or how it is working. For normal operations, a birected diode is always reverse biased. We did not use the forward biased birected diode, but because that will not serve our useful purpose. The capacitance of the birected diode is to be found as C of t equals to epsa A by WD, where CT is the total capacitance of the junction. Aste. Total capacitance of the junction. EPSA is the permittivity of the semiconductor material. Permittivity A is the cross-sectional area of the junction. Cross-sectional area of the junction. And WD, width of the depletion layer. Okay, so like this, we will the capacitance of the varactor diode can be formed. When reverse bias across the varactor diode is increased, the width of the depletion layer also increases. Therefore, the total junction capacitance of the junction decreases. On the other hand, if the reverse voltage across the diode is lowered, the width of the depletion layer will decrease, and if the width of the depletion layer decreases, the total junction capacitance CT will increase. So if you draw the VI characteristics curve, not VI, actually the characteristics curve, then it will be looking like this is the variable resistance and this is the junction capacitance CT. It is in the order of picofarad. So this is 0, this is 20, this is 40, this is 60, this is 80, and this is 100. Now variable resistance will be, this is minus 15, this is minus 10, and this is minus 5. So now the graph will look like so it will look like this. Or little bit more. Like this it will look like. Okay. So the curve between the reverse bias voltage VR across variator diode and the total junction capacitance CT, this is the curve. Okay. We can observe from the curve that CT can be changed simply by changing the voltage VR. For this reason, a varactor diode is sometimes called as the voltage control capacitor. That means Okay. So CT can be changed very simply by changing the voltage of VR. For this reason, a varactor diode is sometimes called the voltage control capacitor. So it is called voltage control capacitor. And the capacitance is in the order of picofarad. It will be 10 to the power minus 12 farad. 1 picofarad is 10 to the power minus 12 farad. Minus 12 farad equals to 1 picofarad.
Hello, hello sir, doubt.
Hello.
सर डाउट
हाँ बोलिए.
सर ये बी आर नेगेटिव कोऑर्डिनेट में क्यों लिए बी आर को बी आर नेगेटिव कोऑर्डिनेट में
रिवर्स बायस है इसीलिए. अगर फॉरवर्ड बायस होगा तो हमारा साथ बायस नहीं होगा. अगर वैरेक्टर डायोड में हम लोग सर्वदा अपना जो बायस है वो रिवर्स बायस लेंगे, इसीलिए बी आर नेगेटिव है. जितना हम लोग उसको वैरेक्टर डायोड का जो रिवर्स बायस है वो जितना हम लोग इंक्रीज करेंगे उतना ज्यादा हमारा डिप्लीशन लेयर इंक्रीज करेगा. तो उतना ज्यादा अगर डिप्लीशन लेयर इंक्रीज करेगा तो हम लोगों का जो कैपेसिटेंस है वो डिक्रीज करेगा. और अगर रिवर्स बायस वोल्टेज उसका वैल्यू हम लोग घटाएंगे तो जो डिप्लीशन लेयर का विड्थ है वो घटेगा. तो डिप्लीशन लेयर का विड्थ घट जाएगा तो हमारा कैपेसिटेंस बनेगा. यही है वैरेक्टर डायोड का प्रिंसिपल. तो वैरेक्टर डायोड में हम सभी जो वोल्टेज लेते हैं वो रिवर्स बायस है, इसीलिए हमने यहाँ पर माइनस लिखा. ठीक है. So applications of varactor diode, where it is used. So we have discussed that we can increase or decrease the junction capacitance of a varactor diode simply by changing the reverse bias of the diode. So this makes varactor diode ideal for use in the circuits where there is a required of a voltage control tuning. So where we will use the voltage control tuning, I will use this varactor diode. So in any type of LC circuits, we will use this resonance frequency or LC circuit. We will use this varactor diode. Okay. So that is the applications of varactor diode. So next our special purpose diode is that is called Shockley diode. So now we will understand about Shockley diode. So Shockley diode was invented by Shockley. So named after its inventor, a Shockley diode is a PN-PN device having two terminals. So how much device? PN-PN. So two diodes are connected. Let us draw the diagram so you can understand. Just a minute. Let me draw the symbol so you can understand this. So this is PN-PN diode. This was P1, this was N1. So this is P2, this is N2. So this is the anode and this is cathode. And this is the cathode. This is our cathode and this is our anode. So if I draw the diagram of this, it will be looking like there is a diode, there is another diode, and there is another. This is the anode, this is the cathode. This is the D3 diode, this is D2 diode, this is diode 1. So symbol, we can draw the symbol of this diode. So this is the anode, this is the cathode, This is the cathode. Okay. So this is our Sockler diode. So this device acts as a switch and consists of 4 alternate p-type and n-type layers in a single crystal. The various layers are labeled as P1, N1, P2, N2 for identification. Since the P region adjacent to N region may be considered as a junction diode, the Sockler diode is equivalent to 3 junction diodes connected in series. Okay. When Sockler diode is in forward bias, that is anode is positive with respect to cathode, diodes D1 and D2 will be forward bias, while D2 will be in the reverse bias. So for the case of forward bias, if I give the forward bias here, so I am giving positive voltage here. So what will happen? If I give the positive voltage here, D1 and D3 will be forward bias. So this will be forward bias and this will be forward bias. But this will remain in reverse bias. Since D2 offers very high resistance, why? Because it is in reverse bias. Reverse bias, that's why it will offer the high resistance. So since D2 is in reverse bias, so it offers the high resistance and the 3 diodes are in series, the Sockler diode presents a very high resistance. Now as the forward bias, sorry, as the forward voltage increases, the reverse bias across D2 is also increased. Now only D2 is why I am including, because D1 and D2 offers very low resistance. So D1 and D2 offers very low resistance. So as D1 and D2 offers very low resistance, the entire applied voltage appears as reverse voltage across D2. So entire applied voltage appears as reverse voltage across D2. So as the forward voltage increases, the reverse bias across D2 is also increased. At some forward voltage, which is called breakdown voltage, it is referred as VBO or breakdown voltage. Breakdown voltage. At some forward voltage, which is called the breakdown, not breakover. Actually, it is called breakover. Sorry for the mistake. Breakover voltage. Reverse breakdown of D2 occurs. Since this breakdown results in reduced resistance, the Shockley diode presents a very low resistance. From now onwards, the Shockley diode behaves as a conventional forward bias diode. The forward current being determined by the applied voltage and external load resistance. This behavior of Shockley diode is indicated in the VI characteristics. Now, when the Shockley diode is in reverse bias, that is anode is negative with respect to cathode. That means what we are doing? We are making anode negative and cathode positive. So when Shockley diode is in reverse biased, diodes D1 and D2 are in reverse biased. So diode D1 and D2 are in reverse biased. Okay. So D1 and D3 will be reverse biased and the diode D2 will be forward biased. If reverse voltage is increased sufficiently, the reverse voltage breakdown point of Shockley diode is reached. At this point, diodes D1 and D3 would go into the reverse breakdown voltage. The reverse current flowing through them would rise rapidly and the heat produced by this current come flow could ruin the entire device. For this reason, Shockley diodes should never be operated with a reverse voltage sufficient to the reach of the reverse voltage breakdown point. So if I draw the Bria characteristics, you will see so this is the x and the y axis. So if I draw the curve, okay. So now it will be breakdown and here will be a case. Okay, so this is VBO. This is A, and this is O. This is the forward voltage. Okay, this is the reverse voltage. Okay, this is I of H. This is forwarding current. Forward current. This is reverse current. Okay, so this is the graph. So what I told, when the Shockley diode is reverse biased, that is anode is negative with respect to cathode, diode D1 and D3 will be reverse biased, where diode D2 will be forward biased. If reverse voltage is increased sufficiently, the reverse breakdown point, that is A. This is the reverse voltage breakdown point of Shockley diode is reached. This point, diodes D1 and D3 would go into reverse voltage breakdown. The reverse current flow through them will rise rapidly in the heat produced by the current flow, which could ruin the entire devices. For this reason, Shockley diode never be operated in the reverse voltage sufficient to the reach of the reverse voltage breakdown point. The above discussion reveals that the Shockley diode behaves like a switch. So long as the forward voltage is less than the breakdown voltage, Shockley diode offers very high resistance, that is, the switch is open and practically conducts no current. At voltage above the breakover value, Shockley diode presents a very low resistance, that means the switch is closed and the Shockley diode conducts heavily. It may be noted that Shockley diode is also known as PNPN diode or four-layer diode or reverse blocking diode thyristor. So what are the names? The names are, sorry, what are the names? The names are PNPN diode. This is the first name. Four-layer diode. Or it can be called as reverse blocking diode thyristors. Reverse blocking diode. What is the spelling of thyristors? Thyristor. Once Shockley diode is turned on, that is, it starts conducting, The only way to turn it off is by reducing the applied voltage to such a value so that current flowing through the Shockley diode drops below its holding point. Holding current. Holding current is divided by IH. This is the holding current. Holding current. Diode D2 then comes out of the reverse breakdown voltage and its high resistance value is restored. This is in turn, okay, this in turn causes entire Shockley diode to revert to its high resistance or switch open state. Okay, so that is our Shockley diode. So these are the two special diodes that we are going to study in this special diodes chapters. We have already discussed about the rest of the diodes last day, and these two are the remaining one. So you have to learn by heart these two. Okay.
Yes, sir.
Okay. So that is our special purpose diode portion. Now we will go for the our next module. I will tell, that is transistors. It is another big module because it has lots of things. Transistors in there will be transistors connection, different types of operation mode. Then there will be transistor biasing. Then uh, different types of special transistors or application of transistors. That will be the things in this transistor. So no confusion, everybody. So let us go to our new chapter, that is our transistors. Twenty-four 1/2020. We will discuss about transistor. So what is a transistor and why we are going to learn about transistor? This is the question here. When a third doped element is added to a crystal diode in such a way that two p-n junctions are formed, the resultant devices is called transistor. So third doped element is added to a crystal diode in such a way that two p-n junctions are formed. The resulting device is known as transistor. Transistor, an entirely new type of electronics device, is capable of achieving amplification of quick signals in a fashion compatible and often superior to that. The transistor, an entirely new type of electronics device, is capable of achieving amplification of weak signals in a fashion comparable and often superior to the realized by vacuum tubes. Transistors are far smaller than the vacuum tubes, have no filament, and hence no need for heating the power, uh, no need to what? Heating power and may be operated in a position. They are mechanically strong, so practically unlimited life and can have what's sorry where I am there. The transistors are far smaller than vacuum tubes, have no filament, and hence need no heating power and may be operated in any position. They are mechanically strong, have practically unlimited life, and do some jobs better than the vacuum tube. So that is why transistor is used. Transistor consists of two p-n junctions formed by sandwiching each other p-type or n-type semiconductor between a pair of opposite types. Accordingly, there are two types of transistor. One is called NPN transistor, another is called PNP transistor. So let us draw the block diagram of a NPN and PNP transistor. What two PN junction formed by sandwiching either p-type or n-type semiconductor pair between a pair of opposite types. That means it will be like this. Sorry, it is little bit wrong because the P portion in between portion will be very small. So NPN. So these are the three terminals. One is on the N side, one is on the another inside, and another is on the this side. So these three terminals have the names. What are the name of these three types? We will tell here. It is called the emitter. Why it is called emitter? Because this section on the one side, it supplies charge carriers, that is electrons or holes. That's why it is called emitter. One side is called the collector. This side is called the collector, the opposite side. Why it is collector? This section on the other side collects the charge. That's why it is called collector. And this is called the base. So a transistor have three terminals. One is called emitter, one is called base, and another is called collector. In that emitter and collector are made up of same semiconductor devices. In between another semiconductor devices is been sandwiched. If it is a NPN transistor, then two N types of semiconductor device is there, and in between this is sandwiched by a p-type devices. Same as there is another transistor that is called PNP transistor, and in that PNP transistor, this is a PNP transistor. So this is P, this is N, and this is P. So here also it has three terminals, 1, 2, and 3. Three terminals are there. This is also emitter, this is also collector, and this is also base.
सर पार्डन सर
Yes.
सर ऐसा समझ में नहीं आ रहा है सर, पूरा क्लास देख रहे हैं पर बट मतलब समझ में नहीं आ रहा जितना आना चाहिए सर।
क्या समझ नहीं आ रहा है वो तो बताओ।
Sir,
ये
can
नया
you
सर कोई भी
start
जैसे कि
please?
ये नया चैप्टर है, इसका नाम है ट्रांजिस्टर।
ये सर ये तो नया
ट्रांजिस्टर,
चैप्टर है,
हाँ,
बट इससे पहले जो हम लोग स्पेशल डायोड वगैरह पढ़े सर, बट मतलब जो आता है ना फीलिंग्स नहीं आ पा रहा सर। जैसे कि मान लीजिए वैरेक्टर डायोड हो क्या रहा है उसमें एग्जैक्टली, वो सब अंदर से फीलिंग्स नहीं आ पा रहा है कि मतलब एग्जैक्टली उसमें हो क्या रहा है, यही नहीं पता चल रहा है। डायोड तो आपने पढ़ा दिया सर, बट मतलब उसमें होना क्या दिमाग में कुछ ऐसा आया ही नहीं। मतलब अगर कोई पूछ देता तो सर उसको एक्सप्लेन नहीं कर पा रहे हैं, तो वैसा फीलिंग्स नहीं आ पा रहा है सर। जैसे कि मतलब पढ़ने के बाद आना चाहिए ना कि हाँ अगर कोई पूछता है तो उसको एक्सप्लेन कर पाए, वैसा तो कुछ समझ ही नहीं आया सर।
हाँ, तो आज तुम्हारा पहला क्लास है।
यस सर।
आज तुम्हारा पहला क्लास है। तुम्हारे पास थ्योरी को जो बुक है, मैंने जो
यस
पढ़ाया
सर।
है, मैंने जो नोट
यस
दिया
सर।
है, क्लास नोट दिया है, आप जाकर बुक को देखो। अगर फिर भी तुमको समझ नहीं पाया तो फिर तुम नेक्स्ट दिन डाउट क्लियर करो। पहले ही अगर तुम बुक नहीं पढ़ोगे, तुम आज पहला क्लास कर रहे हो, तो अगर
यस सर।
जाकर बुक को नहीं देखोगे कि मैंने जो बोला वो बुक में कैसा लिखा हुआ है, तो ऐसा तो नहीं होगा कि यहाँ पर तो मैंने ब्रॉड वर्क कर रहा हूँ। यहाँ पर ऐसा नहीं है कि मैं तुमको बैरेक्टर डायोड लेकर लेकर आ रहा हूँ और फिर इसको एक्सपेरिमेंटली दिखा रहा हूँ कि ये हो रहा है। और इसके बाद आपको बुक पढ़ना है। बुक पढ़कर और मैंने जो बोला है वो दोनों को टैली कर कर आपको अगर समझ नहीं पाया तो तब आप एक्सप्लेनेशन के लिए जाएंगे। पहले ही दिन आप अगर सोचेंगे कि मुझे एक्सप्लेनेशन करना है तो प्रॉब्लम हो जाएगा।
यस
इसलिए
सर।
मैं जो बोल रहा हूँ पहले वो देख लो, क्योंकि डायोड जो है वो आपको डिप्लोमा में पढ़ा है। व्हाट यू मीन बाय डायोड। अब उसके अंदर जो स्पेशल डायोड है उसके बारे में आज मैंने बात किया, जो है बैटरी डायोड और उच्च डायोड। तो मैंने जो बोला है आप जाकर उस नोट को फिर से पढ़ो और बुक देखो। अगर अंडरस्टैंड में प्रॉब्लम हुआ तो नेक्स्ट दिन जब मेरा क्लास होगा तब बताओ पहले, तो मैं क्लियर कर दूंगा। ठीक है।
ठीक है सर।
Okay, sir.
Okay, thank you. So what I am discussing that just a minute, new students have been enrolled. So I am discussing that transistor. What is a transistor? Transistor is another electronics device, and how is this is divides? No, when a third doped element is added to a crystal diode in such a way that two p-n junctions are formed. The resultant device is known as uh, transistor. You can see there are two p-n junctions. Either this is a p-n junction or this is another p-n junction. So how I am doping a crystal diode in such a way that two p-n junction is formed. One is this p-n junction, another is this p-n junction. So that resultant device is called a transistor. A transistor is an entirely new type of electronics device. It is capable of achieving amplification of weak signals in a fashion comparable and often superior to that realized by vacuum tubes. ये बहुत ही बढ़िया चीज है कि वैक्यूम ट्यूब्स की है, उसके ऊपर डिपेंड कर रहा है। मैं बोल रहा हूँ कि ट्रांजिस्टर जो यूज होता है वो है एम्पलीफिकेशन के लिए। सबसे मेन चीज है ट्रांजिस्टर के यूज, वो है ट्रांसफर ऑफ रेजिस्टेंस। और वो ट्रांसफर ऑफ रेजिस्टेंस कैसे करा जाता है ना, एम्पलीफिकेशन। एम्पलीफिकेशन मतलब एम्पलीट्यूड बढ़ रहा है, amplification, that is called multiplication, the rise in amplitude. तो जो भी सिग्नल का फ्रीक्वेंसी था उसका फ्रीक्वेंसी डबल करने के लिए में आप लोग ट्रांजिस्टर यूज करेंगे। दैट मीन्स वीक सिग्नल जो आता है हम लोगों को, वीक सिग्नल को स्ट्रॉन्ग सिग्नल बनाने के लिए हम लोग ट्रांजिस्टर का सबसे ज्यादा यूज करते हैं। जैसे कि आपका एग्जांपल अगर आप लोग देखेंगे कि आपके अगर पास एक वो साउंड स्पीकर है, लाउड स्पीकर, या कोई क्या बोलते हैं बॉक्स है, तब माइक्रोफोन से अगर दूर से आप छोटा सा नोट या छोटा आहिस्ता से भी बात करेंगे तो पूरा हॉल को आपका आवाज सुनाई देगा। क्यों? क्योंकि वहां पर एक ट्रांजिस्टर यूज किया है, और वो ट्रांजिस्टर क्या कर रहा है, जो वीक सिग्नल है, जो आपका मुंह से निकल रहा हुआ जो आहिस्ता से जो सिग्नल आ रहा है, जो लो सिग्नल है या वीक सिग्नल है, उसको पूरा रूम के अंदर वो सुनाई दे रहा है और बहुत ही जोर से, तो वो बन जाता है स्ट्रॉन्ग सिग्नल। सो दैट इज कॉल्ड एम्प्लीफिकेशन। सो ट्रांजिस्टर ये काम करता है। अब पहले ट्रांजिस्टर यूज नहीं होता, पहले वैक्यूम ट्यूब होता है। अब वैक्यूम ट्यूब में क्या होता है, वैक्यूम ट्यूब में फिलामेंट था, वैक्यूम ट्यूब में इसीलिए हीटिंग अगर ज्यादा हो जाता तो फिलामेंट जल जाता तो प्रॉब्लम हो जाता था, पर ट्रांजिस्टर में ऐसा कुछ चीज नहीं है। सो ट्रांजिस्टर मैकेनिकली स्ट्रांग है, प्रैक्टिकली उसका अगर प्रैक्टिकली हम लोग सोचेंगे तो एक ट्रांजिस्टर बहुत ही खराब होने का चांसेस बहुत ही कम है। हाँ, खराब होता है, कब होता है, अगर झटका से बहुत ज्यादा पावर आ जाता है तो वो ऑन हो जाता है, बहुत ज्यादा टेम्परेचर अगर फ्लो कर देता है, मतलब हीटिंग इफेक्ट होता है तो हो जाता है। पर तो वो शॉर्ट सर्किटिंग केस है या ज्यादा करंट आने का केस है। प्रैक्टिकली ट्रांजिस्टर अगर एक डिवाइस में है और डिवाइस अच्छी से चल रहा है तो वो डिवाइस, उसका लॉन्जिविटी बहुत दिन होता है, वो ट्रांजिस्टर कभी खराब नहीं होता, बहुत दिन तक चलता है। उसका कोई ऐसा नहीं कि 3 साल बाद आपको चेंज करना पड़ेगा ट्रांजिस्टर वरना प्रॉब्लम हो जाएगा, ऐसा नहीं होता। इसीलिए ट्रांजिस्टर हम लोग यूज करते हैं। अभी
सर
मोस्ट ऑफ
एक डाउट था सर, जैसे कि सर ट्रांजिस्टर में बोले कि सर एनपीएन से मिलके बना है, अगर मेरा पीएन जंक्शन डायोड भी सर पी और एन टाइप सेमीकंडक्टर से मिलके बना है। हेलो, तो अगर मान लीजिए सर हम दो पीएन जंक्शन डायोड को अगर कनेक्ट कर देते हैं तो वो ट्रांजिस्टर मतलब फॉर्म हो जाएगा सर वैसे?
नहीं हो सकता, क्योंकि आपको देखना है कि डोपिंग कॉन्सेंट्रेशन कैसा होगा। जैसे कि पी और एन जो डायोड है उनमें
जी सर।
डोपिंग कॉन्सेंट्रेशन की अनुपात कुछ अलग होता है, पर यहाँ पर ट्रांजिस्टर जब आप बनाएंगे तो
ओके।
ऐसा आपको डोपिंग देना पड़ेगा कि एमीटर में सबसे ज्यादा डोपिंग हो, कलेक्टर में उससे कम डोपिंग हो, और बेस में एकदम कम डोपिंग हो। अगर ये डोपिंग कंसंट्रेशन हम लोग नहीं कर पाएंगे तो हम लोग का बाद में जब हम लोग ट्रांजिस्टर का जो वर्किंग प्रिंसिपल बात करेंगे या उसका जो कर्म क्षमता बात करेंगे, वहां पर देखेंगे कि ये डोपिंग कंसंट्रेशन चेंज होने की वजह से ट्रांजिस्टर का भी जो वर्किंग प्रिंसिपल है वो चेंज हो जाएगा। इसलिए कोई भी दो डायोड को अगर आप लोग असेंबल कर कर एक ट्रांजिस्टर बनाते तो वो बन नहीं पाएगा। उसको पहले से ही जब फैब्रिकेशन शुरू हो जाएगा, जब डोपिंग करेंगे तो ऐसा ही ट्रांजिस्टर बनेगा ताकि एमिटर में ज्यादा कंसंट्रेशन ऑफ डोपिंग हो, इम्प्योरिटीज, कलेक्टर में उससे कम और बेस में एकदम कम।
मतलब ये मैन्युफैक्चरिंग जिस समय ट्रांजिस्टर करेंगे उसी समय हम लोग
हाँ
डोपिंग
हाँ
कंसंट्रेशन का केयर करना
हाँ
होगा।
हाँ हाँ हाँ।
ओके सर।
Okay, so that is our basic of transistor, and it consists of three terminals, as I told. One is called the emitter, the section on one side that supplies charge carriers that can be either electrons or holes, which is the majority carriers depending upon Np and Pnp. That particular terminal is called the emitter. A emitter is always been used as a forward bias so that it can supply a large number of majority carriers. The emitter of p-type of a PNP transistor is forward bias and supplies whole charges into the junction with the base. Similarly, the emitter of an N-type NPN transistor has a forward bias and supply free electrons to its junction with the base. Same for the collector, the section on the other side that collects the charge is called the collector. The collector is always reverse biased. If the emitter is forward biased, then the collector must be reverse biased. The function is to remove charges from its junction with the base. The collector p-type of a PNP transistor has a reverse bias and receives whole charges that flow in the output circuit. Same as for the collector of a N-type NPN transistor has the reverse bias and receive electrons. The base, the middle section which forms two PN junction between the emitter and the collector is called the base. The base emitter junction is forward bias, allows low resistance for the emitter circuit. The base collector junction is reverse biased and provides high resistance into the collector circuits. So that is the three terminals and the three terminals. So if I draw you the connections or the battery connection or the biasing connection, you will understand the whole thing. Just a minute. So this is a PNP transistor, and I told the emitter side will be forward biased, and the collector side will be reverse biased. And the base will be connected in middle. So this is E, this is B, this is C. This junction is in forward bias, FB forward bias, and this junction is in negative a reverse bias, RB. This is for the PNP. So for the NPN, this is N, this is P, this is N. So this will be forward bias. So negative terminal will be connected with the N side, emitter side, because this is NPN transistor, and here the positive terminal will be connected. So this is E, this is B, this is C. So this is also in forward bias, and this is in the reverse bias. So this is the biasing circuit of a normal PNP and NPN transistor. In each type of transistor, the following points may be noted. There are two PN junctions, therefore a transistor may be regarded as a combine of diodes connected back to back. They have three terminals, one taken from each type of semiconductor. The middle section is very thin layer This is the most important factor of the function in the transistor. The original name of the name transistor, why it is named transistor? If you see the symbol of a transistor, so this is the symbol of a transistor. So this is the base, this is the collector, and this is the emitter. This is the symbol of a NPN transistor, and the PNP transistor is the same. Only one thing is that changed, that is the direction of the current. This is collector, this is base, and this is emitter. This is for PNP. So the difference between the two transistor symbol, these are the symbols, okay? This one and this one are the symbols. So what are the difference? Is the difference of current direction. This is the only difference between the two symbols. For NPN, this will be towards the emitter. That means it is leaving the circuit. And for PNP, it is inward to the base. That is from the emitter to the base. And for NPN, it is from the base to the emitter. So that is very much important.
सर एरोहेड इमीटर टर्मिनल में क्यों सर शो किए, कलेक्टर टर्मिनल में क्यों नहीं शो किए सर?
क्योंकि कलेक्टर टर्मिनल कलेक्ट करता है, पर एमिटर टर्मिनल से एक ट्रांजिस्टर का चार्ज एमिट होता है, मतलब करंट पास होता है। तो एनपीएन ट्रांजिस्टर और पीएनपी ट्रांजिस्टर में जो डिफरेंस है वो है अकॉर्डिंग टू द एमिट ऑफ द रेजिस्टेंस, एक्चुअली एमिट ऑफ द मेजॉरिटी और मेजॉरिटी कैरियर्स। तो एक्चुअली पीएनपी ट्रांजिस्टर में क्या होता है, पीएनपी ट्रांजिस्टर में आप देखेंगे कि पी साइड में हम लोग फॉरवर्ड बायस दे रहा है, मतलब बैटरी का पॉजिटिव टर्मिनल हम दे रहे हैं।
यस सर।
तो इसीलिए हम लोग कर रहे हैं इनवर्ड, और जो हमारा जो एनपीएन है वहां पर मेजॉरिटी कैरियर होल है, इसीलिए हम बैटरी का नेगेटिव टर्मिनल दे रहे हैं। मतलब हम लोग बोल रहे हैं कि बाहर जा रहा है, मतलब जो पॉजिटिव वैल्यूज था वो बाहर जा रहा है, इसीलिए इलेक्ट्रॉन्स अधिक हो रहा है, इसीलिए बाहर का टर्मिनल, बाहर का इंडिकेशन है एमिटर में। बेस टू एमिटर हम लोग तब कर रहे हैं, और यहाँ पर हम लोग बोल रहे हैं एमिटेड टू बेस। यही पार्थक्य है और कुछ नहीं, ठीक है। हाँ, सो द नेम जब भी हम लोग ये बोलते हैं ट्रांजिस्टर, तो क्यों इसको ट्रांजिस्टर बोलते हैं, ये देखिए कि एक ट्रांजिस्टर है 2 p-n junction. One junction is forward bias and the other is reverse biased. The forward bias junction has a low resistance path, whereas the reverse bias junction has a high resistance path. The weak signal is introduced in the low resistance circuit and the output is taken from the high resistance circuit. Therefore, a transistor transfers a signal from a low resistance to a high resistance. That's why it is called transfer of resistance. Understand why the name transistor came? हम लोग क्या कर रहे हैं, हम लोग जब भी फॉरवर्ड बायस दे रहे हैं तो वहां पर हमारा लो रेजिस्टेंस है, और जब भी कलेक्टर इन पे रिवर्स बायस दे रहे हैं वहां पर हाई रेजिस्टेंस है। तो हम लोग क्या कर रहे हैं, जो सिग्नल है वो तो इलेक्ट्रिक सिग्नल हो सकता है, क्योंकि जो साउंड सिग्नल भी होगा उसको हम लोग इलेक्ट्रिक सर्किट में अगर देंगे तो इलेक्ट्रिक सिग्नल में कन्वर्ट होगा। तो इलेक्ट्रिक सिग्नल लोअर फ्रीक्वेंसी और लोअर रेजिस्टेंस से हायर रेजिस्टेंस जा रहा है, मतलब हम लोग क्या कर रहे हैं, हम लोग ट्रांसफर ऑफ रेजिस्टेंस कर रहे हैं फ्रॉम लो टू हाई, इसीलिए इसका नाम हम लोग ट्रांजिस्टर दिया है, ट्रांजिस्टर, ट्रांसफर ऑफ रेजिस्टेंस।
सर मतलब एक एग्जांपल से समझा सकते हो सर, कैसे ट्रांसफर ऑफ रेजिस्टेंस मतलब यहाँ पे कर रहा है ये, मतलब जैसे कोई एग्जांपल लेके सर बता देते कि एक रेजिस्टेंस है मान लीजिए कुछ वैसे
हम बताएंगे एम्पलीफायरिंग सर्किट जब डिस्कस करेंगे ट्रांजिस्टर को, तब हम एकदम एक्चुअली आप लोगों को बता देंगे कैसे ट्रांसफर ऑफ रेजिस्टेंस होता है। पर फिलहाल आपको पहले ट्रांजिस्टर का अंदर का जो वर्किंग कैसा होता है वो पहले जानना पड़ेगा, फिर आपको एक्सप्लेन कर देंगे हम कैसे ट्रांसफर ऑफ रेजिस्टेंस होता है। पर आप फिलहाल के लिए जान लीजिए कि फ्रॉम लो रेजिस्टेंस टू हाई रेजिस्टेंस द रेजिस्टेंस, दैट्स व्हाई इट द नेम इज गिवन of resistance or transistors. Thank you. So now how much time we have done in this class? It is 23rd minutes, so 7 minutes are left. So what we are tell that in this after this, that is regions, that is a collector, the base is
सॉरी टू डिस्टर्ब सर, बट आपकी आवाज नहीं आ रही सर बीच बीच में।
the collector is much wider than the both.
So you
For
are not
our
clearly audible.
sake of convenience, the collector and the hello,
सर बीच बीच में आपकी आवाज नहीं आ रही सर।
पार्डन।
क्या हुआ? Hello,
is not audible.
क्या हुआ?
आवाज नहीं आ रहा सर।
I think there is some, so if you have problem with the video, please disconnect and reconnect. I understand there is no that. So what we are telling that the transistor has three regions: emitter, base, collector. On the doping concentration level, if you think about the doping concentration level, doping concentration is higher. In the collector, the collector is greater than emitter. Which is much greater than base. So actually bit wider than emitter. But for our sake of convenience equals to, we take emitter in this diagram. Okay. Next, according to the doping concentration level,
Hello.
सर आपकी आवाज बिल्कुल भी नहीं आ रही है सर।
हेलो।
अभी क्या सुनाई दे रहा है?
Yes, sir.
सर अभी आ रहा है।
अच्छा, थोड़ा आई थिंक थोड़ा कभी कभी प्रॉब्लम हो जाता है, इसीलिए हो जाता है। ओके, व्हाट आई एम टेलिंग, द ट्रांजिस्टर हैव टू पीएन जंक्शन, that is two diodes. The junction, first junction is called emitter base junction. The first junction is called emitter base junction. And second junction is called collector to base junction. The emitter base junction is forward bias, whereas collector base junction is always reverse bias. So this is forward bias and this is always reverse bias. The resistance of emitter base junction is very small compared to the collector base junction. Therefore, forward bias applied to the emitter base junction is generally very small, whereas reverse bias on the collector base junction is very much higher. Okay, so that is all for today's class. Hope you have enjoyed today's class. If you have any doubt after reading or after studying the theories and these notes, going through your books, Then we will discuss it in the next class previously. First, we will recapitulate the last day's class, and then we will start our rest of the class. So I think the time is over also, because we are on the eve of 1:34. We have a class up to 1:40. So anybody has any questions? Because I will not take any more further new things. Transistor action, working principle of NPN transistor, I will discuss it next day. Working principle of PNP and NPN transistor, and then we will discuss about the transistor circuit as acts as an amplifier, how it acts as an amplifier, that already has been discussed or has been questioned. Then there are different types of connections: common base connections, common emitter connection, common collector connection, configuration, and why they are configured, that we will discuss. Then we will discuss the VI characteristics, and there are different types of current components in different configurations, and then do some numericals. So that is for the transistor first chapter. So hope we will complete it in the, against it in the next class. So anybody has any questions or like that things, you can ask me.
डाउट तो सर बहुत है, लेकिन कल कल सर क्लियर करेंगे, क्योंकि एक बार बुक पढ़ेंगे, इसके बाद फिर कल जो बचेगा उसको क्लियर करेंगे.
ठीक है, so thank you for joining the class. I think everybody's questions has been completed. So see you in the next session. You can leave the classroom one by one. I will be there 2 minutes. If anybody would ask any questions, I can give you the answer. Or rest, you can leave the class. Thank you.
Thank you, sir.
थैंक यू सर. थैंक यू सर.
Thank you very much.
सर एक चीज है सर, जैसे कि मतलब जो मेरा ट्रांजिस्टर जो होता है. हेलो 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 हेलो